One last thing for today, I just wanted you to see a graph of a log function, and I want to talk about just a couple of characteristics about it. We are going to dive much deeper into these in our next lesson where we start transforming both exponential and log functions, but for now I just want to introduce you to the graphs. So we are familiar with this graph. This is y equals bx, and we have seen this in our last couple of lessons. And as long as b is greater than 1, we have exponential growth. And remember that we have an asymptote at y equals 0. Now, log base b of x is the inverse function. And remember, inverse functions reflect over the y equals x axis. So this function, instead of having an asymptote at y equals 0, has a vertical asymptote at x equals 0. So remember, whenever you take an inverse, the x and the y switch places. You can also see the same thing on an exponential decay function and a log function where our b value is less than 1. Again, reflected over the y equals x axis, and these are mirror images of each other. So let's fill in a note here. So we already said that the y axis is a vertical asymptote of the graph f of x equals log base b of x. Since the range of b raised to the x is y greater than 0, then that means that the domain of this function, of our log function, is x greater than 0. And since we've identified many times that our domain for our exponential function goes from negative infinity to positive infinity in the x direction, or all real numbers, then the opposite is true of our logarithmic function. And the range of this function is all real numbers. Again, remember that it's because these are inverses. X's and Y's and everything about them switch places.